All right, new date, another laptop that needs to be saved, but we already looked at this one. This is a video that I put out a couple weeks ago. This is that one that was completely destroyed by a repair shop. We don't even know what it was. Here's the thumbnail, if this refreshes your memory. So I worked on this for hours, rebuilding it, making the motherboard look beautiful, almost brand new again, and still never worked. But the community kind of came together and said, hey, you need to look at this on a live stream. We all got together, we worked on it, and I want to show you what we figured out. Watch this. Well, good morning, everyone. Another Sunday live stream. Last Wednesday, we talked about it. We discussed it, the brain trust, everybody. And we decided that we were gonna mess around with that one laptop that I tried to fix on a video, not yesterday, but the Saturday before that, the one that the repair shop destroyed. That was really messed up. That looked all crazy. The customer decided to just scrap the machine, not even fix it. So I had the laptop here. We're gonna mess around with it. And so here's the motherboard right here. The motherboard looks brand new now because, of course, I made it look brand new. It was a train wreck. Yeah, it looked like someone put plumber's putty on the back of it, and all these components on this one back side of the board were completely destroyed. All these components were replaced all the way over here, all the way over here, all the way over here. But anyway, so we're messing around with this for a little bit for science. We're doing everything for science, that's right. So this is gonna be for science. Flowchart, yeah, flowchart could do it, but the thing is like each one's a little different for like diagnosing things. So whenever I'm interviewing a tech, this is kind of like what I wanna do is I wanna figure out, can you figure out if it's hardware or software first? That's like the first thing you need to figure out when you're trying to diagnose something. Is it hardware or is it software? Is it doing it outside of Windows, inside Windows, or is it doing it only whenever it's triggering on a certain driver or not? If you can isolate that, then you can kind of start ruling out like different things. Like say it's on a motherboard and it's like, does it do it on battery only or does it do it when on charger only? Can you isolate it to the actual board having the issue versus the charging circuit or the power circuitry, you know? Hey, cheer, 1, 2, 3. There you go. All right, so Twitchers can now put messages on the screen when they're sending some cheer, sending some bits. All right, so here's the video thumbnail that we're looking at. This is what the board looked like ahead of time, and this is what it looked like at the end. You can see all the craziness going on. I don't know what it was like plumber's putty, but the customer said they brought it in because of charging issues, I believe. So it doesn't make sense that you would make it look like that. So I ended up having to replace a bunch of components and then it still doesn't turn on. Let's see what it does. I believe it only pulls like 0.05. All right, so let's plug this in. Let's just keep an eye on the power meter and let's see what it does. So if you haven't met Spike, this is my new power meter. He's just a new power meter that I have in line over here. I'm gonna release the software and the plans to build one of these. I may even make them to sell. We're gonna plug it in and see what it does, okay? So we plugged it in, 0.02. This is a resting current, which is perfect. We want that. And even going up to 0.04 for a second and coming back down, that means the capacitor is charging up. Now it is kind of walking around a little bit. I'm not too concerned with that. We could look under a thermal camera, but there's probably not anything, you know, heating up. But we're gonna hit the power button, and this is where the issue comes in. It doesn't power on. So let's get under a microscope. I'll put us under a split view because then I can actually see what's going on at the same time. Here's our power button that I'm gonna trigger it on right here. And I wanna see what gets hot. All right, so I'm gonna power it on. 3, 2, 1. All right, so 0.05, that's it. That's all we got when we powered it on. Gib, thanks for the $20 donation. I don't know why my alerts aren't showing up, but thank you so much. And we'll just take a gander around the board of what's on, right? So thermal cameras are very useful for this. I'm using the Thermal Master P2 Pro right now. I also use the Fleur 1 Pro. Both of these I have linked in the video description if you're interested in kind of taking a look at that. But what we're looking at here is I see something hot over here. And this right here that's hot is gonna be the linear voltage regulator of some sort. So I don't know what it's powering exactly, but it is gonna be some sort of linear voltage regulator. So that's what's warm there. And then we'll come over and take a look over here. We got our EC chip is on, so that means that our EC chip is running, which our EC chip starts the board up. I see something warm right here, right? So that's on the other side of the board. Let's flip over the board. And our chipset is on. All right, so our chipset is on, our EC chip is on. Okay, what else is on? We wouldn't know this without our freaking thermal camera. I mean, that's so useful, right? And that's it. So a lot of these are reflections. You just kind of have to kind of play around with the angles here. What about over here? Is that something? So that is our 1.2. Okay, so now we'll measure the power supplies, just in case. Hello, chat. Hello from Northwest UK. All right, I'm just gonna measure some power rails, but we wanna see what power rails are up and running. Seeing how we have our 5 volt, nice. We have our 3.3, nice. That's our charge coil. This is our 20 volts, right? 20 volts, nice. And then over here, nothing. This should be our, nothing, I don't know what. We found our 0.05 volt power rail. I don't know what that is. This should be RAM maybe? That's our RAM power supply. Let's see what voltages we have on our chipset. 3.4, 3.4, 3.4, 1.8, so our 1.8's there. 3.4, 3.4, 3.4. Now I worked on this board for hours on that video, and then I just had to give up because I don't have time to sit here. And so we're missing voltage here, 0.05. Okay, so this might be our issue. This might be our issue because this should be 1.05. Okay, there's 1.05. So, but this power rail right here is 0.05, which I don't think is correct. And it's been ultrasonic, so yeah, I can kind of give you a rundown if you've already didn't watch the video. I don't know what this is supposed to be. And this is the RAM, which the RAM's not on either. Let's just think about this for a second, just so we can kind of like get our brains wrapped around it, and then everyone can be on board. So this is the board from the video 2 weeks ago. I replaced all the components that were messed up, and I ultrasonic cleaned it. Upgraded membership to save another laptop. Johnny, thank you. And then it still does this thing after I've replaced all those components. Now, some of the components I replaced were actually in this area down here. So I replaced that guy. You know, one thing that I wanted to check, so these two capacitors I had to kind of push together because they were moving around. Are they on the same trace? They are. So this is one pad right here. This is one pad right there. So it doesn't matter if those are together. It is kind of a funky solder job because it started floating around when I was soldering all this other stuff. I remember watching it move around. This guy, I want to make sure this guy's the right one. I mean, all this stuff is messed up. We could have a blown just resistor somewhere over here. What's up? You my boy, Blue? You my boy, Blue? Thanks, Daniel. You know, Old School was on last night. I watched a little bit of it, but I was at the hospital with my mom, so it's like, you can't watch too much Old School with your mom. Do you have a donor board? Yes. So let's pull a donor board that's working, or something that does something, and that way we can get some measurements. Here, I have this board, which is the same board. What? Gifted subs? Thank you. Thank you for all the gifted subs. All right, I'm just gonna put this over this because there's a little bit of liquid metal still on here. Deputy coming in hot. Okay, watching from Kenya. All right, so this board, let's just measure some of the power rails. The one that I'm interested in is this one right here and this one right here. These both measured at 0.05 and then 0. So let's just figure out what we're supposed to have here. So the customer's board is the one that's gonna have the DC jack on it, I guess, or it doesn't have this on it. Here we go. That's a good way of knowing. So this is measuring what? 10 mega ohms. And then this one's measuring, wait for it, 1.6K. Now this board, I don't know, it's not good. It doesn't power on either. It says missing 3 and 5 volts, so who knows what the heck that is. Watching from ABIA for a flight. So ABIA is our local airport here, Austin Bergstrom International Airport. Encore is waiting at my airport to blast off. You know, one thing I want to do, actually, here, let's do this. I thought that I'd already put this back on. There was also, on this board, there was a shorted MOSFET on the CPU. And I know I said in the video that it doesn't matter and I could just leave it off of there, and it shouldn't matter because the GPU in general, you can just take all that stuff off of there. But let's put a MOSFET on there just to make sure it's right. Just to make sure I'm not an idiot. Sometimes I say things so matter of fact, and then I'm just like thinking logically, but logical things don't always pan out, right? So this MOSFET right here I don't have installed because it was shorted out going through the CPU, oh excuse me, the GPU. Shorted out going through the GPU. There's a chance that the GPU's even toast anyway, but maybe that's causing the whole thing not to start, I don't know. In that case, you would take all these off and just disable the whole thing, but theoretically it shouldn't care if that's missing, but we need a 303160. So let's find one. That's a GPU MOSFET, not a CPU. Yeah, so here's the CPU. CPU's fine. It was the GPU that I just, you know, the letters, it's only one letter off, so just kind of stay with me on that. All right, so here's a donor board that I can actually take it off of. Let's see if this one has the same ones. 303160s. So I'll just steal one of these 303160s, brand new. Can we isolate the GPU? Yeah. I mean, there's no short over here though. That's the thing. I mean, in general, like if I just wanted to disable the GPU, I could just take all these off. That's how I do it. I mean, I guess its PWM controller could be bad too. I just don't think the GPU has anything to do with this issue, but I could be narrow-minded, right? That's the problem. It's like, if you just think it, it doesn't mean that it is it. And then if you're like kind of grasping at straws, you might as well figure this out. And then did I do the EC chip on this one too? Let me read my notes. This would help too, because my notes will tell me what I did to it. I took a look at the motherboard, found a mess of chips, caps, resistors that had all been replaced and soldered strangely. there was a sticky liquid. I said sticky, but I said possibly rosin, but I'm not sure. I removed all the chips, rebuilt the area, replaced the components. It looks like new. I also checked underneath the heatsink and found that whatever cleaned the liquid metal off the CPU had spread all over the board. So there was some liquid metal remnants that had been spread all over the board. I also spent a lot of time cleaning the board and sent it through the ultrasonic cleaner 2 times. The board looks like new now, but will not power on past 0.05. Because the 5 volt and 3.3 volt power rails and 1.8 volt power rail are present, I flashed the BIOS and the EC chip, and the board is doing the same thing. The board is too far gone, it needs to be replaced. That was my notes. All my notes are always like that. I'm very thorough with the way that I describe stuff in steps and what I'm doing. So then when the customer gets it back, they actually get a note that just kind of explains exactly all the things I did. Should we replace that? A MOSFET on the GPU. Nearby the chipset, there's also an unoccupied place. That happens, so I'm not super concerned with that. So if you want to look at this board, same. Although this is a donor board, so let's look at this one. There you go. All 3 of these have the same thing. So they didn't populate that on all 3 boards. Why? Because. So should we do the BIOS again just to be sure? And we should put that, I'm just trying to get a game plan, right? What to try. So we could do BIOS a second time, which I'm fine with if we want. Just build a new one or something for science. And then I can put that MOSFET on there. I'd say we put the MOSFET on this just to clear that out of the way. I don't like that it's 0.05 here. And so I feel like I should go grab a test board. Let me see if I have a board in stock. So it's a $750 board. That's why the guy didn't want to fix it. So it has 3070. So the only boards I have are 3060 boards. T3K2W, so this is just the 3060 version of the same motherboard. So we at least have direct measurements. All right, we're ready, we're ready. I don't want to tear the label. Got a phone with a stylus. You know, I had one with a stylus, and then I just never used the stylus. But I definitely don't like typing on phone keyboards. It drives me crazy. It's my little hack to open this up without tearing this, having to print a new label. There we go, okay. So this is sealed up because it's brand new. What's the most reliable Dell laptop in your opinion? Probably, well, you want cost per reliability, because you also want to be able to pay the least for something that's the most reliable, right? That's kind of another way of looking at it. And latitudes in general are going to be the ones that you're going to go by, that you're going to get, because they are made for businesses. Dell offers 3 to 5 year warranties on them. All the rest are going to have 1-year warranties, like Alienware's, or they're going to have 90-day warranties. Would you buy a laptop with 90 days warranty? Brand new, would you? Well, if you buy a laptop that's an Inspiron, which is the consumer grade laptop, and you buy it from like Best Buy or Walmart or something like that, 90 days. It's the most ridiculous thing I've ever heard of. 90 days. It's like, I don't think it will last 90 days. That's what I'm basically telling you. It's so, yeah, exactly. Yeah, what? I've lost connection. My brain is short-circuiting from that. Hell no. So that's the thing. It's like, I used to sell all my parts and only put a 90-day warranty on it. And then I was like, does that mean that my parts should only last 90 days? And then I was like, that doesn't even make sense. So that's why I switched to a 1-year warranty. I don't get a 1-year warranty on all my stuff. I don't get any warranty, actually. I just buy it all. And then whatever I'm stuck holding the bag, I'm stuck holding the bag. That's it. But I put a year warranty on everything because it should at least last a year if you're buying something from me, right? All right, so here's our board. Let's plug it in and see what we're supposed to be getting on that one power supply at rest, and then the power supply after we press the power button. And you know what? We could actually pull this BIOS off of here, although it might be different because of 3070 versus 3060. It's the only thing. 90 days, that's crazy. I can't believe that's crazy. All right, let's go thermal while we plug in this good board. All right, so this board's plugged in. You can see Spike. Now, Spike's not bouncing around as much. Yeah, Spike's bouncing around. I take that back. All right, so we have, same thing. We have that LDO or some sort of linear voltage regulator right there. Low dropout. There's our EC chip is on right there. I don't have the board powered on, so we don't have the chipset on the other side. Sorry, that reflection in the middle is that my ring light, and it's really hot right now because I have it on full blast. Maybe I should turn it down. If I turn it down, then it doesn't get so hot, and so therefore it doesn't reflect as much the heat. All right, powering on. CPU, GPU, all this stuff's getting really hot. I don't want to leave it on for that long. This already got up to like 78. So what I want to do is, I unplugged it just now. I want to, at the same time, there, we'll do this view here. I want to know what the voltage is here, and I want to know if the voltage is here. Those are the two of them that I'm more concerned with out of everything. All right, so resting voltage, I just have it plugged in with it not on. I just want to see what that resting voltage is. Nothing there, and nothing here, okay? So now we're going to trigger it on, which I can't do on this side. I have to flip it over. All right, so I'm going to trigger it on, but I got to go fast because I don't want to overheat this board, because this is a good board. All right, 1.8. 1.8. So those are both 1.8s. Okay, so I think we identified our issue then, or the lack thereof, what we're missing. How's that? That's another way of saying it. So $500 sale on a Lenovo 16-inch with a 3-year extended warranty. Basically getting extended warranty in Norway is pointless. I have a Latitude 5000, a Latitude 7000, and 3000. Meh. So 5000, 7000, 3000. 7000 is going to be the best because these chassis is going to be made of metal. 5000 is going to be kind of a mix, and the 3000 is going to be just, it's like an Inspiron, basically. So don't get a 3000. All right, so we did identify that this power rail right here and this power rail right here should be 1.8. So why are we getting 0.05 on this one and then nothing on this one? I don't know. So let's look for signals, and I'm trying to think, do I have a schematic for this? I probably do. What's the resting voltage on my meter? You missed it. So the resting voltage on when it's not on is going to be the same as this board. It kind of sits at 0.02 and it does a little flicking around. So it does a little spikiness. So it was the same as the other one. And then the when it's on, you know, it's obviously just, it's ramping up a lot. Let's take a look at this board and see what inputs we have. I'm going to plug in the chip. It's not on yet, so let's think about that. You know, we could have a bad dual MOSFET here. So this is a dual MOSFET. So we're going to have 2 MOSFETs in one. This is using a, where's the chip that controls that? I'm assuming this controls that and this one controls that. What do you think? Does that sound about right? This one would control this, and I bet there's another MOSFET on the other side. But the way these power rails are all working, and I don't know how familiar some people are and some people aren't, but basically you'll have a high side and a low side MOSFET, and then you'll have the output coil in the center, okay? So think about it like that. We basically have this as the output center, and then we'll have one side tying to ground, one side of this MOSFET tying high, and then the high side's gonna be pulsing, and the low side's gonna be pulsing, and it's pulsing in a pattern that will allow it to output a lower voltage here. We need 1.8 here, so there's gonna be 20 volts going into this, and then it's tying to ground, and then the output's coming here, and then this one needs to be 1.8 also. So there's 2 MOSFETs in this one, there's 2 MOSFETs in this one. Like this one right here is a single MOSFET, and then you would have to have another one somewhere else, like usually on the other side of the board. All right, so let's start measuring our chip. I'm assuming this is the one that controls that. Let's just figure out where the input is, the enable, and all that type of jazz. Was it 0? Costco run, I have to fly this morning. Oh, really? Well, thanks for coming by. There's a low likelihood we're gonna be able to fix this just because I already worked on it a bunch, but we'll see. I have faith in you guys. You guys are gonna figure something out. All right, so the board is off right now. So when we measure it right now with it off, we should get nothing there. This is our VCC. So we have our 5 volts to power this chip. This is the only thing we're missing here to enable it. So we should get a signal there. I'm gonna power it on real quick. I just want to see what voltage we're getting on that pin. That chip could just be bad or something like that, but I'm assuming we may have a short somewhere. Is it powering on? There we go, 0.05. I mean, the symptom is very similar to like a BIOS issue because that's what we deal with all the time, but so we're not getting an enable here. So is this enable supposed to be 3.3? Probably. What do you think? If I just short those out, it should turn on? Let's do it. Crazy Nate coming in hot. So what I'm gonna do, we're not gonna hurt anything, or we're gonna hurt a lot of things, but this board's already broken. So I'm gonna measure right here on the output, and then I'm going to short this 3.3 over to this line that's not getting an enable signal and just see what it does. So right now we're not getting any voltage on there, and then when I short it across, I get 0.05. So, oh, now it's on at 0.05. Is there any heat over here? I don't see any heat though. Okay, think about this. Okay, 1.3, 0.5, 1.8. Yeah, if it boots all, okay. I mean, you know, what would be easy is just to replace these 2 things right here, change that out, or change that out first. Or should we put this thing back on because we were talking about doing that? Or should we flash the BIOS because we were talking about that? Start with BIOS flash. Let's just put this MOSFET on, we'll flash the BIOS, and if that doesn't work, then we'll change out that 1.8 chip, maybe. All right, let me see what BIOSes I have and see if I made a fresh one or if I just used one that I knew was good or what. So if I look for X15, it pulls up all of them. If we do only R1s, then we have these. So let's flash this one on there just to be safe. What chip do we have here? There we go, 25R256JV. So it's an RJV. I've already backed up this person's BIOS, so I don't worry about backing it up. We're just going to, actually I need to select the chip first. Let's see, so we need an RJV, it's that one, select. We're gonna load X15 R1, clean ME, new BIOS from RIP. So when I say it's from RIP, it just means it's from a working board. So you re-enter into the BIOS from the label on the back. Yes, that's what I usually do. When I clear a service tag, then I just put the service tag back in, because the service tag is like a serial number that explains about the laptop. And if you take a rip from another machine and then you clear the ME region, then you can flash it on there, but it will put that service tag on that machine. So this one still has a service tag in it that's not going to match this motherboard. So if you run your service tag on Dell's site, it's going to think it has different specs. Okay, so that's done. No harm, no foul. Now, if this doesn't work, we're gonna put that MOSFET back on the GPU. This probably won't work, but we'll see. All right, keep an eye on Spike right here. See what he does. Usually if the 1.8's missing, you gotta think about this too. The 1.8's missing, then usually, so I don't know why I said the 1.8 was there, but I think it's because I found 1.8 on the chipset. But the 1.8 power rail's missing, then it's usually not the BIOS, because I usually look for 1.8, 3.3, and 5, and if all those are there, then it can be the BIOS. But see how it's doing the same thing? All right, so we're gonna pull this MOSFET off of here. Yeah, so 0.02 to 0.05. So whenever I don't have it on, it's 0.02, and whenever I press the power button, it goes to 0.05, when it's supposed to jump up to an amp. And I'm okay about saying I'm wrong, definitely, because sometimes I'm so, you know, I feel like I'm so logical about my conclusion that I kind of get blinders. All right, so that's gonna go right there, in that beautiful spot. So I'm just gonna preheat the board a little bit before I put flux on it. That's the way I like to do it. A little black force goodness. Now to me, this shouldn't change anything, but I'm just gonna put it on there since it is a missing component on the board. Maybe it's checking to see if that exists, and if it doesn't, then it doesn't allow the board to turn on. Some boards are okay with it, and some boards aren't, maybe. So maybe they had some sort of safety mechanism that I'm not aware of. And that would put me in the I was wrong camp, which I'm okay with, because then I learned something. If you don't fail, you don't learn. We're just trying to heat this thing up enough so we can set it in place. There we go. All right, so I got it plugged in, 0.02 again, so that's the resting voltage, 20 milliamps. Power it on, keep an eye on Spike there. Nothing, let's try again. There we go. 0.05, that's it. So same thing. So we're still missing the voltage probably over here, or we still have a low voltage over here that's not supposed to be there, right? So, well, now we have 0.08 here. This is supposed to be 1.8. This is supposed to be 1.8. Maybe if this one's missing, this one won't start, or vice versa. We're supposed to have 3.3 enabled here. Cheers, 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 thank you. All right, and now if we short these two things together, we figured out that we can get something happening here. Nothing, okay. Should we move on to trying to fix this one, or should we move on trying to fix this one? Because this one's kind of on, but this one's not on at all. So this is a board from stock, and it's missing too. Let's go back and do this real quick. I just want to go back to where I rebuilt everything. Just to be safe, I want to make sure that all this looks correct back here. What does this guy go to anyway? And then, are we missing a couple items here? Here, can we see them both at the same time if we do that? I just want to make sure we're good with my rebuild here. So this is the bad board. This is a good board from stock. All right, so you guys just examine there. There's a missing cap. Where? Where? You I spy something? Over PUSO2, okay. PUSO2's here, right here? Here, YAR, there's a missing cap there. Good call, okay. We also should make sure all these resistors are good, but there's a missing cap. Now that shouldn't do anything, but let's go ahead and put it on there. Good job, guys. That's what you're here for, my scouts. Most of the time capacitors don't matter, but sometimes they do. All right, so let's grab that one. I think it's this one. Yes. Yes. Okay, so that's what we're gonna do. Cap it, light it, light the candle, what? It goes direct, 4.7 matters. Okay. So it may matter, huh? This one may matter. It could be a magic 1 volt cap. It's magic. Okay, that's good. Let's check some of these resistors too. I mean, I think I've checked all these resistors, but usually when you have a blown resistor is whenever you have an issue. 60K, 0, 2, these are probably all 2s, 2, 2, okay, and then these 4.7s, 4.8, 4.9. And usually you'll see a hole in it. Okay, let's see what that does. Okay, this was our donor board. I don't want to get all these boards mixed up. Okay, so this is my brand new board. Let's move that out of the way. Okay, I don't want to steal a part off my good board. All right, here we go. You ready? Okay, powering it on. 0.05, same. All right, so now do y'all want to go back and focus on this area? Should I just change this out? But it's missing the signal, so therefore it's not coming from there. So this is the 1.8 that's probably, I was saying, is present. So if we're not getting it this 1.8 over there, so let's measure over here. All right, let me turn it on. Board is on. All right, so this is our, there's our 1.8. So we have our 1.8 here. So this is supposed to be the signal. We should have 3.3 on this side, and we should have 1.8 good here, but we're not getting our 1.8 good there. So in circuit, it says we have a 4K, 3K, 2K, 1K. If I measure the other way, just in case it's filling up capacitors, 1.8K. Interesting. I mean, that's gonna be in parallel with a lot of stuff. So I just wanna make sure, do we have 3.3 here? We got 3.3 on that side, and we got nothing on this side. The board's not on yet. Let's go, I'm gonna go to the thermal camera while I do this, just in case we see the atomic explosion. So I'm just jumping across. The board's not on yet, so I'm just going to jump across. Actually, I'm going to measure the 1.8. 1.8's not on right now, so this shouldn't do anything, I don't think. But okay, we are seeing spike is measuring some sort of jump up in current, which makes sense because we have something that's shorting to something else, or trying to power on something else. So spike's doing something when I'm pinching it. Okay, and then now I'm going to power it on while I'm holding that, because I'm crazy. We got 250 milliamps, and if I let go, it goes back down. So whenever I enable this, I get 250 milliamps. Where's our 250 milliamps going to? So when I pinch this, do we go to 250? We do. Oh, the board, wait, 0.08? Wait, back down? Wait, what's getting hot? We're getting somewhere. Kind of. We might be getting somewhere, or we might be making things worse now. So holding that down. I want to see what's getting hot. Wait, did it just, wait, did I get to 2 amps just then? We got the 3 amps. Holding it down. Did we just get the 3 amps? Okay, I'm going to unplug it, plug it back in. It definitely doesn't like to have that on whenever the board's not on, so let me turn the board on, and then we'll pinch that. Huh. Well, I want to figure out what's getting hot. Okay, so the board is on. Pinch this, hold it. There we go, 1 amp, 2 amps. The board's starting. CPU started, everything started. What does that mean? So let's have a little powwow real quick, just to kind of think about this. So us jumping that resistor, which basically had a 3.3 on one side, and then it was supposed to get a good output of the other chip, and that other chip's not outputting good. By jumping it, we kind of tricked it into saying it's good. So why are we missing that good output? Are we missing that because that chip's not outputting it? Or are we missing it because that chip's detecting a fault somewhere else that's telling it? Or the resistor's gone? Should we just pull the resistor off and measure it and see if it's not a 10K anymore? I think resistor could be plausible. We measured it in circuit and it was lower than that, but that could mean it's in parallel with a bunch of other resistors, so that doesn't really mean anything. So let's pull it out of circuit. Let me see if I have my tweezer measurer thingies. I hate measuring those little tiny resistors out of circuit, so I do have some of these tweezer thingies that I can hook to my meter, and I can pinch them. You know, if we fix this, I can call the customer and just say, hey, we fixed your board, because he scrapped the machine, so I have all his parts. We can just reassemble it, and they will be very happy. I'm gonna hook up these gauges. I'm gonna pull that resistor off the board, because we could just replace it, but then I wanna know exactly what the what, right? So we're gonna pull this guy off of here. And it's funny, because I had measured it before. You could tell that I had some scratches on there. I mean, now I've scratched it more, but somebody's been working with this resistor. Take this guy off of here. Prime suspect. The resistor doesn't have a hole. I actually think it's, I think it's that guy more than anything, but we will see. But there it is. All right, so we're gonna try to use this guy to measure with. And I'm in voltage mode. Let's see, resistance, 10K. But I'm gonna put a new one on anyway, because I just kind of crushed it a little bit when I was squeezing it. So I think that we have an issue with this chip then. So we are getting, this chip does produce a 1.8, but it's not producing a 1.8 is present, everything's A-okay. Now send the output here. So let's just pull this guy off and replace him, and then we'll replace this also, and then we're good. All right, and this chip is off. I'm surprised Lead Farmer's not telling me what this K lowercase d, capital DDA means. Because this stuff to me just means gibberish. It means like it's like a joke. It's like, come on, they need like a cheat sheet for all that stuff. That's why donor boards are like my lifeblood. Here's a donor board, brand new donor board, same chip number. So we'll just transfer this chip over. So brand new chip going on. I haven't put any flux on yet, and people are gonna be like, what the? Why are we doing flux yet? Because we're gonna do this. You see those lines were bridged and everything? So now that we tacked it on there, now we put the flux. There we go. And then now we can reflow it, and everything will be beautiful. Look at that. And the chip just moves right in spots. I can see a couple bridge lines there. There we go. All right, and we need to get that resistor replaced. It's old 10K. It might be easier to fix the donor board. You're funny, probably. Now, these donor boards usually are going to be the lost causes that are worse off than this one, maybe. There we go, tack it, reflow it, and brand new. This board is ready to rock and roll. If this doesn't work, what do we do then? Because we're missing that signal. Why would we be missing the signal if this doesn't work? If we jump it, it works. We cry. That's a little bit more on point. Okay, here we go. Okay, let's reset Spike. Spike got up to 3.26 amps. So Spike has been reset, and plug it in. Good. Power it on. 0.05, 0.06, 0.05, 0.07. So, still not working. So I'm not mad at this because we have a way of turning it on, right? So if we have a way of turning it on by just jumping a resistor, there has to be a logical, ooh, look how beautiful this is. Should have taken this thing off, shouldn't I? God, what are you thinking? So if we jump this, right, with our tweezers, I don't have it plugged in right now, but if we jump this right now, it will send a good signal over to these two 1.8 power rails, and this will get a good signal here, and it will get a good signal, I believe, here, and then these will both turn on and start working, okay? And the board starts to boot. The question is, we replace this chip, why are we not getting an output here? Because this is what produces the 1.8 here, and we are getting a 1.8 there. I bet we have a blown resistor somewhere. Let's check the 0 ohm. Let's check, well, that's a capacitor. Let's check the 0 ohm here. 0. I don't know what all these are supposed to be. So 8K, we already replaced that guy. 40, 65. Let's see. Inputs PU1801 are what is busted. So PU1801. Should I turn the board on to measure this? So I'm in resistance mode. So here's our coil output. We're at 1K. And then this was a 1.8. And then this was another output. We don't have any shorts in this area, if that's what you're thinking. This is a 19 volt input. It took a second for it to charge up. And then this was, what? That's ground. And then this was 43. Okay. All right, let me turn on this chip then, and then we'll just measure all the voltages everywhere. So we have to turn the board on. So this is board off. We'll measure what it is with resting voltage, and then we'll measure it with it on. Voltage mode. This should be the 19 in, and then this one is nothing. And this is our output is right here, so nothing. And then this is this other output. Let's see, put that pin there. Nothing. Here, I'm gonna zoom in a little bit so you can see better. All right, so this one we got nothing here. This is with it off, like I said. So this pin here, 3.4. So we have 3.4 there. This one is right here. Nothing. This one is here, 3.4. So our 3.3. And this one is nothing. And then this is nothing. So what's this pin right here on the end? I don't want to be careful. 0.2. 0.3. Why are we getting 0.3 there? That doesn't seem good. This one's nothing. That's grounded. That's nothing. Okay. So why are we getting 0.3 on that one? Ohms measure for PS good pin. I think we're measuring in the kilo ohms. There's no short there. Just watched it, left a comment. The turn off Windows device driver installation updates. Yeah, but if you turn off your driver updates, then you're not getting any driver updates. If you just turn off UEFI capsule updates, then you don't have to worry about the BIOS update. You checked the 1.8 after replacing the chip. No, I did not. So let's turn it back on. Okay, now it's on. So now we'll check our voltages again. So 1.8's there. This is 5 volts here. So that's enabling fine. 20 volts is there, which is powering the chip, which is fine. And then this one, we're just not getting our voltage there that we need. This one's still 3.3. This next chip was nothing. We have 0.6 here. This one may be the issue, because why do we have 0.6 here? That doesn't seem right. Wait, and then it just turned off. Did the whole thing turn off? Yeah, the whole thing just turned off. So now we're not getting 1.8 here again. So it looks like, okay, now it's back on. Now we'll come back over here. I just want to see what it's getting. It keeps turning off. I'll wait for it to come back on. It's not coming back on. Ohm's law says it's broken. All right, well, let's just do this for fun, for science. I'll put a 0 ohm right here. I'll take this 10K off, we'll put a 0 ohm here, and then let's just see if we can get the board to post and get a picture for science. So let me grab a 0 ohm resistor, which is basically just a wire. So I'm gonna save this 10K off to the side in a happy little spot. So we're gonna just put a 0 ohm on here because we're crazy. But if we get picture, then we're gonna be stoked. Okay, let's just hook this up for science quickly and see if it turns on. Or actually, I'll see if it powers on with my new fix. So plugged in, see how it's pulling a constant 115 milliamps constantly because we have that shorted. So it doesn't like it, what we did. Ooh, this chip's on fire. Oh, wow. I think this chip must be bad. Well, I think that's the way to do it. Unless this chip doesn't want to be on without the board on. So that's going to be this one right here, which is the one that controls this other 1.8 that has that missing or no stuff. Let me try turning it on and see if that is no longer hot. But look, 65 degrees. All right, let me turn the board on and see if it cools down. There's a chance that it doesn't want that voltage there because it's not on, but when we press it to power it on, it wants it and it needs it. And we don't have a spike in this view for some reason. I don't know why, but so it's still at 61. Hold on, it didn't turn on, I don't think. Or did it? No, it didn't. Oh, it's on. Board's on. Okay, is this hot still? Still burning hot, but the board is on. Okay. Dude, bro, who was it the one that said to put a 0 ohm there? You were awesome. So what I'm thinking is going on here is that it cannot give a all good signal because it's detecting a short on that chip. And we just kind of forced it to say, no, it's all good. It's all good. And then that chip is getting hot. So I think we can just replace that chip unless that's powering something that's shorted. So let's just measure the outputs and inputs and all around that chip. But yeah, I think that we just need to replace this. So who was it that did it? All right, OPEX. So we're gonna measure across here. Just looking for one of these to be shorted or something. That's 13 ohms. 13 ohms to what? 13 ohms does not seem regulation. And that's fine. Just took a second for it to charge up. Okay, so we got 13 ohms on this line. Let's see what we're supposed to have on that line. This beautiful chip right here. So we're not supposed to get 13 ohms on this line. So either this chip's shorted or something else, but I don't think that it would be something else because it just goes straight into there, right? So we're getting 13 ohms here. And on this side, we're getting 18. Well, we're getting 18 on both sides now. So if we take this off, then we can see if it's on this side or that side. Oh, wait. Can y'all not even see what I'm doing? Sorry. I hate when I do that. Okay, so I moved, this was installed here, I moved it over. So this is going into the chip, 18 ohms. This side is going to our peak good, and that's fine. So we know that the issue's in that chip. All right, so we're gonna take this guy off, replace it, and then we should be good. Replace the chip, put it back, the 10K. Yep. If we fix this, I'll be very happy, and I'll be very satisfied for the day. It'll actually make my weekend. You don't know what it takes to do these videos. Okay. I'm still happy with that 0 ohm replacement. I'm still just thinking in the back of my head, I was like, that was such a good idea. It doesn't look regulation. Let's see if we can clean that up. Maybe I should do a video that says, can you fix a laptop using plumber's flux? Okay, that's regulation. Should we measure to see if that resistance is better? Hey, no longer do we have that crazy measurement there. I bet the board's fixed, people. You guys are geniuses. Back to the hot tweezes. So this is our 0 ohm, temporary 0 ohm. We don't need that guy anymore. Where we're going, we don't need him anymore. Okay. The question is, do I still have my 10K over here? If I could see it, it's just a speck, right? Okay, coming in slow. Got it, there you are, just a happy little 10K. Come on, baby. There we go. Hot tweezers work really good on these Alienware boards only if it's not a ground plane. If it's a ground plane, then you're in just jeopardy because this thing is so thick, it's hard to heat it up enough, so you have to add heat. But if you're just getting something that has no ground plane, it's just like an inline resistor, no problem. You ready for this? I'm upping my odds that this is turning on to like pretty high. Like pretty high. Here's your chance to, we won't do a vote. Reset spike, thank you. We'll reset spike. Spike's my power meter, by the way. Just put a 1 in chat if you think it's gonna work, and a 2 in chat if you don't think it's gonna work, and a 3 in chat if you think it's just gonna do something different. All right, so we got some 3s. Most people are saying 1s, which is nice of you. We got some 3s, something different. But I don't see any 2s in there, which is awesome. Don't see any 2s. 1.5s. Crazy Nate's Raw Dog and Repair School. I think that would be a fun shirt. All right, spike has been reset. Plug it in, 20 milliamps, perfecto. Going thermal, powering on, 3, 2, 1. Oh, Lord! Okay, you guys are the geniuses. Okay, let's do this. Let's put a heatsink on it. So we have current, we hit 3 amps. Look at this horror show of a heatsink. God. So we're just gonna put on some Arctic Silver, which is right there. Just a happy little dab in the middle. Did you replace the 0 ohm? I sure did. Yeah, so we put that on there temporarily, which will try to force on that one chip, or force on the chip that it didn't like, and we figured out it was shorted, so we replaced that. I replaced the 0 ohm that we moved out of the way temporarily to see if the enable was no good on that. And so everything's back to factory. So if you ever want a big tub of screws like this, all you have to do is take apart a laptop, and every single time you put it back together, you keep 1 screw. Just kidding. All right, plugging it in, let's reset max on spike. Spike has been reset. Here, I'm just gonna turn off this other meter here, that way it's zeroed. And there we go, plug it in. So it's resting at 0.02. And see, it is moving around quite a bit, like you're saying, up and down, but it is pretty flat at 20 milliamps. So I'm gonna open the lid. It didn't come on. I'm gonna press the power button. And we have keyboard backlight. You guys, you ready for this? Okay, turn back off, which is good. It should come back on. 3 amps for a second. Come on. Come on. Come on. 4 amps almost, 5 amps, 5.6. And we have picture! I saved another laptop. Actually, you guys saved another laptop. We're in the BIOS, set the BIOS. This is freaking crazy. So this is really, 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 really good news. Now, hopefully everything else works on it, and we'll figure that out later, but I've got to call this customer who was just like, oh man, okay, just scrap the laptop. And I get to call him and let him know that we looked at it on stream and he could watch the stream, and we fixed the laptop. Boom, okay. It was Apex, right? Was the one who said to put the 0 ohm there? All right, shout out, the winner of the stream. All right, so there you go. We were able to get this thing working again. Kind of a strange one. Had to kind of go down another rabbit hole in order to fix it. So multifaceted, probably had, I don't know, 7 hours into this repair, but laptop's up and running, and I'm happy to report I saved another laptop. I called the customer. He was super happy, super stoked. I'm getting this sent back to him tomorrow. I'd love to know your thoughts on this one, and thanks for watching. I can't believe I saved this laptop.